Hello students, you are welcome to sirMATHS. Today we are going to discuss perfect square as it concerns JSS2, which is the equivalent of grade 8. Grade 8, JSS2, we're talking of perfect square. Which can also be called square of a number. Square number. Now, when we are talking of a perfect square, it can be called perfect number or perfect square, or square number, whichever way, it's just the same thing. We are talking of a number that resulted from an integer multiplying itself. Square or perfect square is an integer that resulted from another integer multiplying itself. What do I mean by that? 16 is a perfect number. It's a perfect square. Why? Because it is the result of 4 multiplying itself. 4 times 4. So we call this a perfect number because it is the product of the square of another integer. The product of the square of another integer. So that is what we call perfect square, or perfect number or square number. Now we have 1. 1 is a perfect number. Why? Because 1 times 1 will give you 1. Let's have an example up to a certain point. This 1 is a perfect number because 1 is 1 square, which is 1 times 1. 4 is a perfect number because 4 is 2 square, which is 2 times 2. And we have 9 is a perfect number because this is 3 square, which is 3 times 3. 16 is 4 square, which is 4 times 4. We have 25. 25 is 5 square, which is 5 times 5. We have 36, which is 6 square. This is 6 times 6. And we have 49, which is 7 square. That is 7 times 7. We have 64, which is 8 square, 8 times 8. We have 81, which is 9 square, 9 times 9. All these are perfect squares. These are perfect squares. I will expect you to continue from here up to 30. Up to 30. That is up to 30 square, which will give us 900. This is 30 squared, which is 30 times 30. This is perfect square. I hope that is clear. Just a number multiplying itself. If 10 times 10 will give you 100. So 100 is a perfect number. It's a perfect square because it's the result of 10 multiplying itself. 10 times 10. That is for that. Let us look at square root of numbers. Square roots of numbers. The square root of a number is the number when it multiplies itself will give you the given number. I take it again. The square root of a number is the number where when it multiplies itself will result to the given number. For example, if you ask what is the square root of 16, when you tell the person that the square root of 16 is 4, that means this 16 is a result of this 4 multiplying itself. So 4 is the square root of 16 because 4 times 4 will give you 16. There are ways of getting this. You may not even need that thing you call calculator. You can use the LCM continuous division to find your square root. It must have to go in twos. Like this very 16, you keep on dividing by the factor that can divide it without a remainder, starting from the smallest. 2 can do this to give us 8. 2 can go again to give us 4. 2 can go again to give us 2, and 2 again to give us 1. We are talking of square root. It involves twos. So this is 1, this is 1. So we now say that the square root of 16 is equal to 2 times 2, and that is the 4 we have here. Using the LCM continuous division to get your square root. It has to be going in twos because square root is 2. That is that. That is square root. Now let us find the square root of some numbers. The square root of some numbers. The square root of 1 the square root of 1 will give us 1. The square root of 4 will be 2. Okay. This is the square root. We are talking of the square root. This is the number here. And this is the result. This is the result, the square root. We have 9. The square root of 9 will give us 3. The square root of 16 will give us 4. Let me put it this way for the square root of 25 will give us 5, and the square root of 36 will give us 6. These are our square roots. That is the number when it multiplies itself. When it multiplies itself, will give you a perfect number. We call that square root. Square root. So you can continue with this up to 300 or 900, which is opposite of what we did before. The square root of 900 will give us 30. Remember what I said. Use LCM continuous division. How did I get this very 5? I have 25 2 cannot divide 25 without a remainder. 3 cannot do that. 5 can do that. So 5 here will give us 5. 5 dividing 5 will give us 1. So this is 1 because we are treating square root. So we now have our square root of 25 to be, sorry, this is 5, to be 5. What about 36? How do you get 6 as the square root of 36? This is our 36. 2 can divide 36 without a remainder. That will give us 18. 2 can still divide 18 to give us 9. 2 can no longer do that. 3 can do that. 3 here will give us 3. 3 again will give us 1. So we now have, this is 2. This is 3. So the square root of 36 is equals to 2 times 3. And that is 6, which is what we got here. And on and on and on and on. Let's say we have up to the square root of 144, which is 12. How did we get the 12? We use the same LCM continuous division by saying 144 divided by 2. This will give us 14 divided by 2 is 7. 4 divided by 2 will give us 2. 2 can still go without a remainder. This will be 3, remainder 1. 1 and this 2 is 12 divided by 2 is 6. 2 can still go to give us 18. 2 again to give us 9. Then 3 to give us 3. And 3 to give us 1. Therefore, the square root of 144 is, this is 2, this is 2, this is 3. That is 2 times 2 times 3. 2 times 2 is 4, and 4 times 3 is 12. We have found that the square root of 144 is 12. That is for the square root of numbers. I will encourage you to continue this up to the square root of 900. 900. And that will give you 30. Using the same method we have used here. And keep away that your calculator. Use the more reliable calculator, which is one is in your head, more reliable. And follow this and solve our square root. Continue from where we stop up to here, 900, which has given us 30. Because 30 times 30 will give us 900. So my dear, that is what we have today. I still encourage you to ensure you subscribe to sirMATHS. Just tune your notification so that you'll be updated daily on this discussion. Click to subscription and the notification button. Every discussion, you'll be getting it. Thank you for participating in today's journey in this mathematical world. God bless you. We'll meet again next week.